I'm Preston Spratt here at Sprattronics Learning Lab, and this is our next lesson for our LEGO robotics program. This week, we're going to be testing the efficiency of two different grabber designs and determine the best design based on a specific test criteria. What we'll be doing is we're going to start by building a couple of grabbers, and these grabbers are modular. And what that means is you can take a motor off and attach a new tool very quickly without having to completely disassemble what you've already made. So we will be building a controller, grabber number 2, and grabber number 1 together. But before we start, I have just a few questions for you to think about. And our first question is, why do people typically use some sort of grabber to pick up trash? Why might they use a tool for picking up garbage? Maybe it could be garbage around the school, maybe it could be garbage on the side of the road, but why do people use a grabber in order to do that? Maybe you've volunteered with a group before to do a neighborhood cleanup or a park cleanup. I know for Cub Scouts and Girl Scouts, they often go clean trails or area parks where they do a lot of their meetings. But why would you use a tool to pick up trash? Some reasons could be just you don't know what you're picking up. Something could be dirty or have disease on it. If you're picking up glass or metal, it could be sharp, it could harm you. And so it's important to use a tool whenever you're picking up trash or something you don't know how it's going to react with your skin. So we're going to build two grabbers today, and I want you to think, how could we decide which grabber is the best? I have this grabber that has some soft fingers. I have this grabber that has some larger fingers, but I want to know what could be a test that we could do to figure out which grabber works the best. And then finally, have you ever watched a product review online? So the last thing that you're going to do today is we're going to build these grabbers, we're going to test those grabbers, and then I want you to determine which one's the best. So, have you ever watched a product review online? Maybe you've been thinking about buying a computer, a laptop, or a cell phone, or maybe a video game, maybe a board game, maybe some clothes or some camping equipment. You may have watched a review video online or read a review. There are whole magazines dedicated to reviewing things. There are magazines dedicated to reviewing all products, to reviewing cars, to reviewing camping equipment, running equipment, kayaks. You name it, there is probably a whole market just of reviews for that market. And this isn't too hard to find, just on YouTube. I know that oftentimes the very top watched videos are often reviews of products, new tech devices, and video games. But in a product review, they often tell you what something is really good at. They might say, this right here is really cheap. This cardboard grabber is made out of cardboard, sustainable materials. It's easy to operate. You just push the arm forward and backwards, and it opens and closes. However, it's not very reliable. It tends to fall apart quickly. So, 3 things that we're going to do today. We'll start by designing and building and coding our claws. Then we'll conduct a test to figure out which claw is best at picking up which type of objects. And then finally, your challenge will be to go and explain to somebody which claw works the best. We're going to go through building instructions for the claws. We're going to do a new project for coding these claws, and there's lots of ways to code them. We're going to show you a very simple way that will give the claw as much gripping power as possible. And then finally, we'll give you some experiments or some tests to do using your kit. All right, take out your kit. You should have everything disassembled and ready to go. We're going to use a lot of pieces in this build today. But let's dive in to building now. All right, from our home screen, we're going to scroll down here, and today we're going to click on Building Instructions. And these are where all the directions are to build lots of different things, Most of these you can build with your Spike Prime kit, but there are a few that you would not be able to build, and that would be like the advanced driving base parts. They just require an expansion kit, but about everything else in here you could build. We're going to go down here to the grabbers. That's our build for today. So we'll click on grabbers, and we're going to build this in 3 parts. Our first part is going to be the controller, then we'll build grabber 1, and then grabber 2. I have my camera turned around so you can see my hands in front of me because there are some steps in this build that you want to make sure you line things up, and this is one that we end up providing the most hand-holding in whenever we build this build in our lab. So let's get started by clicking on the controller, and first thing we'll need is a hub. And I like to lay it out so that my hub matches the picture that's in the directions, and I see that my button is facing to the right, and I'm going to put 2 Technic pins right here in the bottom. Next, we're going to take one of these tan pieces, and we attach to it a little yellow wire clip, and that's going to go on the back side into the yellow part of our build right there. Excellent. Now for 2 more Technic pins, they're going to go into the top of our hub. Next up, we'll use one of these purple plates. We use these for so many different things when we build here at Sprattronics, but we're going to put 4 Technic pins into each side, or 4 into it total, 2 on each side. And we are ready to attach that to the top with 2 pins pointing out the same direction as these 2 pins. Next, we are going to take 2 of our 15 long beams, and they're going to attach into that bottom pin and then up into that purple pin. So we're starting to build a handle. We'll take another one of these purple pieces and add 2 pins into each side. And then we'll take 2 more pins and put them in the top of it. Next, we're going to find our force sensor. We used this when we did our rhinoceros build. We call it a touch sensor or a force sensor. It just measures how hard something is pressed on it. And we'll attach these 2 pins into the black part of the force sensor. So when you turn it over, you'll see these 2 pins are covering up the holes. These 2 pins are just fitting out the back. And we want to build a button for this force sensor, so we'll use one of our rubber tires. And to hold it into the force sensor, we're going to take one of our tiny red axles and press it down into it. Now I have my pieces all ready for me. If you need to pause this video throughout so that you can find the right pieces, feel free to do that. You might do lots of pausing. Or if you're comfortable building on your own, you may just skip ahead to the end of this build. But if you have any questions or if you get stuck on a step, I want to have these building directions available for you. All right, here is our touch sensor. And in the back of that touch sensor, we're going to add 2 more Technic pins. Just like that. And then this is going to plug into the very top of our handle. So 2 pins in the very top, 2 pins in the bottom, and then our wire can come around the side and clip right into the yellow. And we're going to plug this into port E down here at the bottom. All right, so we've got most of our handle finished. we're going to keep on working on this. And we need 2 of these blue beams that are 7 pegs long or have 7 holes in them. And these blue beams are going to attach underneath our touch sensor, making a nice sturdy hand grip. So we're going to double check that we're plugged into E. And then this is our hand controller, and that is finished. You can set that off to the side. And now we're ready to build the next step. So I like to start with grabber 1. And so we'll click on grabber 1 and we can start building. We'll start with one of our blue L pieces, and we will put 2 Technic pins into it. And during these steps, I like to just double check that if I hold my Lego up, does it match the picture exactly? And so if I have the L facing down, I have these 2 pins here. This is going to help later on if you're building everything facing the right direction. Next, we need 2 more of these Technic pins to go into the bottom part of the L. And then into this top part, we're going to attach, I call them these H's, but these double sets of pins. So that looks just like the picture, so I know we're building it correctly. And now it's time to add a motor. So when I look at my picture, I see that we turn the wheel of the motor so that the circles line up. That means that it's at 0, 0. And then I put it down on my table face down. That's how it matches the picture. I see the blue part is down on the bottom, and then I see that the big blue base is out and to the right, and that's going to let me attach this piece incorrectly on the far side of it. So that looks good. Now we're going to build another L shape, but this time it's going to look just a little bit different. Put that off to the side. I have my L facing down. When I hold it up, I see though that my pins are going to go on the back side of it. Again, I hold it up to see if it matches what my picture shows, and my picture shows the pins coming in from the back side. Moving on, we're going to add 1 of these onto the back side. And now we are going to add 2 of the Technic pins onto the back side as well. We've basically made the reverse of what we made last time. So mine looks like this. If I want to match the picture, it looks like that. And it's going to plug into the other side of my motor. Now for another one of these purple square pieces. The nice thing about them is they're just very rigid, very strong. It's going to go into this first set. And I think a good thing to do is to put the wire facing down into this groove right here. And then we can put this piece on. And then things will stay where we need them to be. All right, we're now going to build into the top of this, and we're going to need 2 Technic pins, and they're going to go on either side of this spinning axle here. Inside that axle, we're going to put a short 3-beam yellow. And down here at the end, to just add some extra strength and support, we're going to add a yellow 3-beam right across. Great, we're on step 10 now. The first step of step 10, we are going to slide one of our purple beams that's 5 long right down the middle of this. And we should have a Technic pin on each side of the yellow axle and then 2 open spaces. We're going to fill those open spaces with 2 more Technic pins on either side. I'm going to set this off to the back. And now we're moving on to step 11. We'll start off with one of these white pieces, and inside one side of it, you're going to put one of these tan axles. That's a pin on one side, but an axle shape on the other. And if I match this up with the picture, I have the tan piece on the far side from me. Now we'll take one of these blue pieces that have a pinhole and an axle hole, and we'll attach the pinhole side onto that pin that we have poking out. Next, we'll take the motor assembly we have so far. That axle hole that we have available is going to slide down onto that yellow axle. And so right now, this piece you can turn, this piece is attached into the motor, and we want it facing down. We want this white piece down right along this purple piece. Again, we'll set this off to the side and grab 2 yellow elbows and 2 4-long black axles. And we're building both of these side by side. We built this the other day in the lab. We had to give lots of help during these next few steps because folks were trying to jump ahead. They knew what they wanted it to look like at the end, but weren't building things step by step. Onto each of these black axles, we'll take another one of these blue axle and pinhole pieces. It just slides down so it's facing away from the yellow axle piece. We'll do that with this other one. Again, it should be facing the opposite direction of this one. So I'll lay both of those down. If yours match, awesome. And then into that back piece, we need 2 more pins. And a pin will go here. And a pin will go here on the top side. So you'll notice those pins are poking up next to the axle with the yellow elbow facing down. 2 more of these purple 5 beams. And the end piece is going to go through the axle, and the pin is going to go into the second one. So it'll end up looking just like this. I'll do that twice. All right, we need 2 more yellow elbows, and they are going to face the same direction as the lower elbow. It's starting to look like a pair of claws. And now we'll take this rubber piece, which a lot of times we use for decoration. I like this build because we actually use it for a purpose. And we have the parts of our claw. Now it's time for everything to come together. And if we attach this all correctly, this claw will work just fine. So I take my motor, and I see that I'm going to attach this purple beam, not the very last hole, but the second to last hole, into it. And I still had that white piece facing down, so now it's trapped in there. And then in the upper one, again, same thing. This blue part's going to be facing down. I'm pressing this into the pin, the second from the last pin, so that on both of these, the final pin is open. There we go. So step 21, we need another pin in the top. Right back here. And then we're going to take one of these pins that have an axle on the other side, and it is going to lock into that white piece that we have on the bottom. So I think you can see that. I might have to turn it a little bit so that it lines up, and I press in, and you'll see that it comes out the other end of that white piece. So now this arm is attached to that white piece underneath. This one still moves freely though. All right, our last step, we are going to take this H-shaped piece, and this is just a really good frame that doesn't wobble, it holds everything tightly, and we are going to attach this top hole and this bottom hole into the pins we already have. So we set the H right on top, press down firmly. You'll know you've attached it in the right spots whenever there's a pin in that part and a pin in the very bottom part. So they're going to be diagonal from each other. So now we've got it so that whenever we turn this motor a certain distance, our claw will open and close. All right, so that's grabber 2. We can go ahead and attach this now onto our hub, and then we can go through and build grabber number 2. But I think before we do that, we will code this to test it out and see if it works. The cool thing about these claws is they're modular, which means you can just pop them on and off relatively quickly. These 2 pins just plug into your hub right here. Got it upside down. These 2 pins plug into your hub. This purple piece holds things nice and tight. And then you can go and take your wire that we've made sure was coming out of the back and plug it into port A. All right, so now you've got your claw built. Let's go ahead and code this claw and test it out to see how it works, and then we'll work together to build grabber number 2. And then I have some challenges for you to do with these claws. So let's click next, we'll say done, and now we're ready to go home and click on New Project.
Once we click New Project, we have an option to click Icon Blocks, Word Blocks, or Python. I'm going to give my project a name called Grabber. I'm going to click on Word Blocks, and I'm going to click Create. This takes me to a screen with a blank coding slate. I need to connect my hub by clicking the Connect button. I've already updated my hub, so I'll click on Green. I'll power on my hub by pressing the big button. It'll turn on. I press the small Bluetooth button, and I'll know it's connecting when it starts to make that beep and flashes. I'm ready to click on Open, select my hub once it shows up, and then connect. Once your hub is connected, we need to give ourselves some more code options. When you make your own project, you have lots of options over here on the side, but we can add some more options to this list. Now, I'm going to click on this little plus sign with code blocks in the bottom left corner, and I want something called More Motors. I click on More Motors, and then I can click the X to close out. And now I have a new selection on the bottom left called More Motors. Now, I want to go ahead and drag out this start motor at 100% power because we're going to need that in a moment. I'm going to get rid of when program starts. I really don't want anything to happen when the program starts. I want things to happen only when our button is pressed. And so I'll drag out this when. Right now it says sensor A is pressed. And I want to make sure this says when sensor E is pressed. And I'm going to drag this up, and I want motor A to start, but I don't want it to go at 100% power. It would turn to the right, and I don't think anything would happen. I'd like it to go to the left. So I'm going to say negative 100% power. So now when I press the button, it's going to start the motor to go left. If we were to run this program right now, though, we've never told this to stop, and it'll just keep on running our motor to the left, which will close our grip and keep it closed. So we need to add another function, and that's going to be when E is released. So when we let go of pressure sensor E, what do we want to have happen? I want to use just a regular motor block, and I'm going to have it turn clockwise to the right, and I want to change that to 0.5 seconds. And so what this should do is when I release the button, it should make our motor run the opposite direction for half a second, which will open up the claw. This is a very simple code with a lot going on. I want you to test it out and see if this code works. So press the play button and then squeeze E. It should start your motor turning to the left at negative 100% power, which will close your claw. And when you release the claw, it should turn the opposite direction. The motor should turn the opposite direction and open the claw back up. This code is saved to your hub on program 0. And so all you have to do is turn this hub on now, and this claw is ready to work. Go ahead and give it a try. So now that you've got a program that works to test your claw out, I want you to test and see what types of objects can this claw pick up. Is it good at picking up large objects or small objects? Is it good at picking up round objects, oddly shaped objects, square objects? How about heavy or light objects? I'm going to stop this video and make a second part that shows us how to build grabber number 2, as well as our challenge for this week.